Here we go, guys. So first and foremost, this is our next UH quiz. And the attempt date, I would like for you guys to attempt today, but the attempt date is actually tomorrow. Today is the 9th, so the attempt date is tomorrow. And we're a little behind. So instead of a week, we're just going to short you guys 2 days. So it's going to be due on Tuesday, which is 01. What's Tuesday? Let me see. Tuesday's the 14th. 01/14. So we just short you guys 2 days of what it usually is. I think that's enough time. So there it is, guys. We're gonna have to be shortening them instead of a week. We're gonna have to be doing 5 days for the next few quizzes. That way we can catch up. And yeah, so there it is, guys. It is on. Okay, try really hard not to use the acronym. MVT stands for mean value theorem. And you can use the mean value theorem when you're continuous on your closed interval and differentiable on your open. If you have a function, as long as it doesn't have any corners or vertical tangents, you're gonna be able to use it. Does that make sense? All right. What is mean value theorem? Instantaneous rate of change equals average rate of change. Average rate of change is something you've been doing since you were in junior high. It's just y2 minus y1 over x2 minus x1. It's the slope of the secant line. It's your average rate of change. And then what you have on the left-hand side is an instantaneous rate of change. So that's all the mean value theorem guarantees. All right, so here we go. Number 1, the function f is graphed below on the interval 0 to 10. Give the number of values c between 0 and 10 in which to satisfy the conclusion of the mean value theorem. So we can use the mean value theorem because you're continuous on the closed and differentiable on the open. The slope, or I guess let me just draw the secant line first. Here's your secant line. Oh, didn't draw it anywhere near. Can't draw it perfect, guys. There we go. Kind of perfect. There's your secant line. I am looking for tangent lines that are parallel to that secant line. So I just go down the curve. So a little bit past that max there. There I am. That's parallel. And then a little bit before that min. That looks parallel. And then a little bit past that max. That looks parallel. So there it is. How many tangent lines do I have that are parallel to the secant line? 3. And there it is. Yeah, we took this quiz. I took this quiz this morning before anyone came in. 7:20. It's on the upper left-hand corner when I did this. So yeah, there it is, guys. All right. I don't know why I was gravitated towards that little timestamp. I tried to take away the timestamp, but okay. Anyways, determine if Rolle's theorem applies to the function f of x equals 3 sine 2x between 0 and 2 pi. Guys, Rolle's theorem is a special case of the mean value theorem, only with an added restriction that the y values are both the same at the endpoints. Rolle's theorem is just that your instantaneous rate of change is 0, or the average rate of change is 0. But it's a special case of the mean value theorem. It actually precedes the mean value theorem, but it's okay. We're not talking about the history of math here. So let's find out. I'm going to go f of 0 equals 3 times sine times 2 times 0. Sine of 0 is 0, so this equals 0. So that means f of 2 pi better equal 0 for Rolle's theorem to apply. 3 sine of 2 times 2 pi. Well, 2 times 2 pi is 4 pi. And sine of 4 pi is also 0. So does Rolle's theorem apply? Yes. The y values are the same, see? So 0 minus 0 divided by 2 pi minus 0. Average rate of change is 0. All right, next. I'm going to take my derivative and I'm going to equal it to 0. So here it is. F prime of x equals 3. What's the derivative of sine? Cosine 2x, then times 2. And I know some of you guys are already super advanced and you just go ahead and write 6 immediately. That's fine, but I like to still showcase what we're doing here with chain rule. So 6 cosine 2x, and I'm going to equal this sucker to 0. Are we still okay? Okay, a little bit of baby pre-cal, not extreme. Divide both sides by 6, it's still 0. Cosine 2x equals 0. So I have this statement. I guess you could, I guess it just depends on how you think. You can either, no, I'm not even going to bother saying that. Use your pre-cal skills. Inverse, or arc. So 2x equals plus minus arc cosine of 0 plus 2 pi n. You don't have to do plus minus if you don't want. You can say pi over 2 and 3 pi over 2. But plus minus takes care of both answers because pi over 2 and negative pi over 2 is the same as 3 pi over 2. And then what am I going to do next? Divide everything by 2. Divide by 2, divide by 2, divide by 2. So x equals plus minus. I guess I'll write it like this first. No, because that's what the top line is. All right. Where is cosine 0? Pi over, and pi over 2 divided by 2 turns into pi over, perfect. What happened?
Go back to the last question.
I'll put it here on the side. Where is cosine equal to 0? At pi over 2? Yeah, but the plus or minus takes care of it. Plus, yeah, and I'm dividing by 2, so that turns into a 4, right? Okay. All right, here we go, guys. Here are my answers. x1, take the positive one, pi over 4 plus pi n. x2, take the negative one, negative pi over 4 plus pi n. I'm looking between what and what? 0 and 2 pi. So let me see if I can fit it right here. X equals, one answer is pi over 4, comma, that's from x1. The other answer, negative pi over 4 plus pi over 4. Okay, let me help you with this common denominator. Just put a 4 over 4 like this, see? Common denominator. 4 over 4 like that. What's negative 1 plus 4? 3, so 3 pi over 4. And then that's it, because if I add another pi, then I'm outside that domain because you've already added 2 pi to that one. And so that's it for the positive ones, but well, yeah, let's keep going with the, you know what, I was wrong. We can still keep going. 1/4 plus pi. All right, here we go. This one, 1/4 pi plus 4 plus pi. So, yeah, timeout. I'm all flabbergasted. 1/4 pi plus pi, but I already have my common denominator, so that's 4 pi over 4. So 1 plus 4 is, so 5 pi over 4 is another one. And then you take the 3 pi over 4, and you add another pi. So what is 3 plus 4? 7. So 7 pi over 4. So all the 1's over 4 on the unit circle between 0 and 2 pi. Yeah, that's it. Did I get anyone confused on how we got those answers? Okay. Ask me, Lopez. Ask me. Okay. Yeah, I think I'm trying to talk so fast, and I think I messed up. Oh, what happened? I didn't hear you. What happened? I didn't hear. Oh, yeah, I want to laugh too. Oh, was it mean? Okay, here we go. Determine the function satisfy the mean value theorem between 0 and 1. It's a square root function. You don't have any vertical tangents. You don't have any corners. So mean value theorem will apply. You are defined at 0. You are defined at 1. Cool or not cool? Okay, here we go. Let's find the average rate of change. F of 0. All right, guys, focus. 2 square root of 1 minus 0. Well, 0 squared. But square root of 1 is 1. 1 times 2 is 2. F of 0 is 2. F of 1. 2 square root of 1 minus 1 squared. 1 squared is still 1. 1 minus 1 is 0. 0 times 2 is 0. Right. Here's what I'm doing, guys. I'm doing the right side of the mean value theorem. I guess let me write mean value theorem over here. F prime of C equals F of B minus F of A over B minus A. Remember, the right side is the average. I'm doing the right side right now. Here it is. I'm going to go F of 1 minus F of 0 over 1 minus 0 equals 0 minus 2 over 1 equals negative 2. Sometimes I'm tempted to skip so many steps, so I have to really fight my urge to skip steps. So, ask me, miss.
You said the left side is the average?
No, the left side of the instantaneous. That's the derivative. The right side of this is the average. Well, I recorded it, so I can rewind it a little bit and see if I said left is average. Pretty sure I said right, but. All right, are we still okay, guys? All right, here we go. This is my average rate of change. Now I'm going to equal it to the derivative. So take the derivative of this. I'm finding the x value where my instantaneous rate of change is equal to my average rate of change. So I'm going to rewrite it real quick. 2 parentheses 1 minus x squared to the power of 1/2. Here we go. F prime of x, and I'm going to go slow. Half of 2 is 1. If you want to write the number 1 there, that's fine. Not a big deal. 1 minus x squared to the negative 1/2, because you subtract 1 from the exponent. And then chain rule times the negative 2x. The derivative of negative x squared. All right, a little bit of algebra, not extreme algebra. Negative 2x over the square root of 1 minus x squared. And I guess technically I'm supposed to put the letter c because it says the number c there. But understand that c just means the exact x value, x value. I'm going to equal that to negative 2. And sorry, YouTube, if you feel like I'm not being technical enough here. All I'm doing is I'm just solving for x, guys. Does that make sense? So here we go. Now it's just algebra. This is what you guys have issues with, but hopefully your algebra is getting better with this. So multiply by the denominator. So here's what I have. I have negative 2x equals negative 2 square root of 1 minus x squared. Are we okay with that statement? I have a negative 2 on both sides. Ask me, because I make mistakes. Did I make a mistake? No, everything looks good. I have a negative 2 on the left. I have a negative 2 on the right. It's a product. If I divide both sides by negative 2, do those negative 2's go away? Hell yeah, they go away. Bam, bam. The only way to get rid of a square root is to do, well, there's not the only way, but here, the way that we know is to do a what? You square it. Squared and squared. That negative 2 is not there anymore. Remember that. So I have x squared equals 1 minus x squared. Oh, it doesn't cancel out. Be careful. Next, move the negative x squared from the right to the left. So it sums up to 2x squared. And now I'm going to divide both sides by 2. So I have x squared equals 1/2. We're so close, guys. I don't want x squared. I want x. What do? The square root. Don't say root because root's a 0, right? Square root. The square root. So you get x equals, square root of 1 is 1. So you get 1 over square root of 2. Laws of exponents. So rationalizing it. Plus minus square root of 2 over 2. So catch up to here. I did laws of exponents. Square root of 1 over square root of 2 and then rationalize it. Times square root of 2 times square root of 2 over square root of 2. So square root of 2 over 2. So be careful. Plus minus. Yes. Perfect, Lopez. You said it perfect. They're going to try and trick you guys. You're going to get to here. Your math is beautiful. And you're going to circle. A lot of you are going to get this one wrong because you're going to circle letter C. Yep. Is it letter C? No, obviously you can see it's not letter C. You have to find an answer within the interval. The negative one is not in the interval. Write that down in your notes. Write that down in there. Put in there that it must be an interval. Put must be an interval. And then circle the positive one. Must be an interval between 0 and 1. Got him. Oh, did I get it from you?
I don't know.
Oh, got him. I'll stop. Oh, okay. Here we go, guys. There it is. Let's go to the next one. The next one, question 4, is not even asking for a mean value theorem. It just wants to know where is the derivative equal to 0. All right. Well, let's find that out. It says find the x value where the derivative equals 0. Take a derivative. F prime of x equals 1/3 times 3 is 1. So it's going to be x squared minus 1. Equal that sucker to 0. It depends on your, I was going to say your lifestyle, but it depends on your math aptitude on what you want to do. You can do difference of squares. You can move the 1. Whatever you think is easiest. It does not matter to me. In the morning, first period, did this. X squared equals 1. Square root. X equals plus minus 1. All right? They didn't do that. We did that. But or you could say that's the difference of squares. X plus 1, x minus 1. That still equals 0. X equals negative 1. X equals 1. Guys, it does not matter. Correct math is correct math. So there it is, negative 1 and positive 1. Cool? Okay. Let's go to the next one. All right. We're halfway because I think there's only 10 questions. Yep, we're already halfway, guys. Look how fast that was. Find the intervals on which this function is decreasing. Okay, so write this down. This is a side note. Side note. F of x decreases when f prime is negative. This is a polynomial. If this were a delta math question, I think delta math would have counted it wrong because you increase and decrease on a closed interval. And notice that all of them are parentheses. That's fine. It's a technicality. Some textbooks, there's always so many fights. If you Google this, you'll see a whole bunch of forums about the debate within closed brackets versus open parentheses. You increase and decrease on an interval, so it should be closed bracket, but it's not a big deal. Who cares? You guys ready? I'm finding where this is true. Here we go. F prime, 3x squared minus 108. I'm going to equal this to 0 to get my critical numbers. So let's see. What am I going to do? Let's move the 108. 3x squared equals 108. Divide both sides by 3. X squared equals 36. Square root both sides. X equals plus minus 6. Do a sign chart or a railroad track. Call this F prime. Negative 6, 6. All you care about is positive or negative. I'm going to use this line right there. This one right here. I'm going to choose a number to the left of negative 6, like negative 10. Negative 10 squared is 100. 100 times 3 is 300. 300 minus 108. Positive or negative? Positive. Put a plus symbol. I'm going to choose a number between negative 6 and 6. The easiest one, in my opinion, is 0. 0 squared is 0. 0 times 3 is 0. 0 minus 108. Positive or negative? Negative. I'm going to choose a number to the right of 6, like 10. 10 squared is 100. 100 times 3 is 300. 300 minus 108. Positive or negative? Positive. Where am I decreasing? Where is f of x decreasing? Negative 66. That's the interval that is decreasing. I want to put a bracket. There it is. Negative 66. Yeah, there it is. We're good. Cool or not cool? All right, let's go to the next one. Find intervals on which f of x is increasing. Okay, well, there's no vertical asymptotes on this one, so we don't have to worry about that. Increasing whenever f prime is positive. So put that as a side note. I'm looking where the derivative is positive. I'm going to have to do quotient rule. F prime of x, bottom, x squared plus 49, times the root of the top, 6, plus or minus? Minus top, 6x, times the root of the bottom, 2x, all over bottom squared. Guys, we don't care about the denominator. The denominator is always going to be positive. It's just algebra now. So we focus on the numerator. Does that make sense? Don't make life hard for yourself. Make life simple. Just focus on the numerator. The denominator is always positive. Maybe make a little side note on that. I'm going to distribute that 6 like this. So let's see. 6x squared plus, if I have 6 quarters, that's $1.50, but I don't have 50. Oh no. What is 6 times 49? 294. Man, I was way off. I have to double it because a quarter is not 49 cents. Sorry, I was trying to do something else. 294 minus 12x squared. Just focus on the numerator. I'm going to get my critical numbers for the numerator. Equal that to 0. So let's see. Negative 6x squared. Oh, look, it's going to come back anyway. So I'm going to have to divide by 6 in a little bit. Plus 294 equals 0. I'm just solving for x. Move the 294 to the right. Or I guess, well, I already did it. I already said that. Negative 6x squared equals negative 294. Divide by negative 6 both sides. I'm assuming that's going to have to be 49. X squared equals 49. And I say that because in the top I had to multiply that, and that's what we got. You told me 294 or something. No, the negatives go away because, yeah. Square root. X equals plus minus 7. Those are my critical numbers. I do a sign chart. I'm going to call that f prime. Negative 7 and 7. All you care, which one am I looking at? I'm looking at this one right here. This one right there in I was going to call that purple. In blue. I'm looking at that one in blue, guys. That's my derivative. You don't care about the denominator because the denominator is always positive. So looking at the numerator, make life simple for yourself. If I choose a number to the left of -7, like -10, -10 squared is 100. 100 times -6 is -600. But when I add 294, it's going to stay negative. Do you guys see that? Pick a number between -7 and 7, like 0. 0 squared is 0. 0 times -6 is 0. 0 plus 294 is going to be a positive. Pick a number like 10. 10 squared is 100 times -6 is -600. -600 plus 294 is another negative. They want it increasing. So this is my derivative graph or my derivative sign chart. So where's my derivative positive? And I'm going to change the parentheses to brackets. But yeah, here it is, guys. All right. Bless you. What happened? Oh, all right. Before you start this one, before you even start this one, I want you to notice that this function at positive and -1 has vertical asymptotes. I guess I'll just write it as x equals 1, x equals -1. Nothing cancels out, guys. Look. You can't factor out the numerator. And the denominator is x plus 1, x minus 1. See? So you have vertical asymptotes of -1 and +1. So you cannot cross those lines. So okay, I got to be careful. They are not critical numbers. They're vertical asymptotes. Okay, here we go. Increases, f prime positive. I have to do quotient rule. Bottom times root at the top minus top times root of the bottom all over bottom squared. We don't care about the denominator because the denominator is going to be positive always, besides the -1 and 1. But those aren't critical numbers. Those are vertical asymptotes. We focus on the numerator. Let's see. I guess let's distribute this. So -2x cubed minus 2x minus 2x cubed minus 2x. Oh, yeah, you're right. Thank you. Or else I would have gotten it wrong. I would have been like, what the heck? That's just the numerator, guys. I'm not focusing on the denominator. These 2x cubes cancel out, and I have -4x equals 0, and the only critical number I get is 0. Here's my f prime. I'm going to put -1. That is a vertical asymptote. 0, 1. Chav, why aren't you putting something, like, why'd you put -1 in there? Like, I don't understand. It's not a critical number, guys. I have a vertical asymptote. I have to stop because you can't cross it. Okay, ready? All I'm doing is plugging into this one. Actually, you just focus on this. Focus on the -4x. You don't care about the denominator. The denominator is always squared, so it's always positive. If I choose a number to the left of -1, like -10, negative times the negative is a positive. Put a plus. If I choose a number like -0.5, you got to pick a number between -1 and 0. -0.5, negative times the negative is again a positive. If I choose a number like 0.5, negative times the positive is a negative. And if I choose another number bigger than 1, like 10, -4 times 10, that's a negative. So they want it increasing. So here's where a lot of people get it wrong. Do they even have that option, -infinity to 0? Okay, they didn't try to trick you guys. It's increasing from -infinity all the way to -1. You do not cross -1 because it's a vertical asymptote. And then you increase again from -1 all the way to 0. So there it is. Boom. This one, it's okay with a parenthesis for all of them because they're vertical asymptotes. So this one is actually perfect because you're just going to be going up forever and it doesn't touch. What? Oh, yeah, you're right. Bracket of the 0. Yeah. All right, there we go. You get a 0 for the original function and nothing cancels. There's no factors that cancel out. So if you have a 0 in the denominator, you have a vertical asymptote. Yeah, like if you would have had something like x plus 1 over x plus 1, x minus 1, then at -1 you have a hole and you have a vertical asymptote at 1. But if you have a factors that don't cancel out with any of the factors in the numerator, then you have vertical asymptotes because you cannot divide by 0. You're undefined. So it's not part of your domain. You know what I mean? Okay. All right, guys. We're almost there. We just got 2 questions or 3 questions left. Some of them are kind of heavy with algebra. I'll try to make it as painless as possible. I'll try. Find the intervals on which this is increasing. Okay, you guys ready? I gotta do product rule with a little bit of chain rule, but it's baby chain because this is not an x squared in the inside of that. All right, here we go. F prime. Oh, by the way, try to have correct notation. Some of you guys just get started and you don't write anything. You just tell me that it's a derivative, guys. First, 2x squared times root of the second, 2 parentheses 4 plus x closes to the power 1 times 1, so there it is, plus second, 4 plus x close with a square on it times root of the first, 4x. All right, do I see anything? I do. All right, let me see if I can make it pretty, guys. 4x squared parentheses 4 plus x close plus 4x parentheses 4 plus x close it squared. Okay. I see a lot of stuff that I could take out. It depends on your level of algebra. If your level of algebra it needs like help, then go slow. Do you guys want me to go slow or try? Yeah, I'll go slow. All right, look. Do you see this is a product and that's a product? Notice that I'm underlining the products. I see a 4x squared and I see a 4x. Can I factor out a 4x? So here's a giant 4x factored out. And what do I have left? I'm going to have an x, parentheses 4 plus x, close, plus 4 plus x, close, squared, close. So here's that is a parenthesis and that is a parenthesis. I was going to do 2 things at one time, but I didn't want to freak you guys out. Now look, this is still a product. And here's my term, and there's 2 of them in there. Is there something that I can also factor out? 4 plus x. So here's what I have now. 4x, parentheses, 4 plus x, close. There's a big one. And then here is another parenthesis, and then I'm going to have x, and I already took out that 4 plus x, plus, and only one of those 4 plus x's came out. So I have another 4 plus x. Does that make sense? Okay, perfect. Here it is. So here's my final form. 4x, parentheses, 4 plus x, close, open, 2x plus 4. I could have factored out a 2 there, but that's fine. I'm going to set that equal to 0. Yes, I realize that 2x plus 4, you can factor out a 2, but I'm going to leave it. Are we okay? So, by the way, you don't have to do those 3 lines. You could have done like 3 of those lines. You could have done it in 1. But I'm just showing you, the algebra steps. So here are my critical numbers for increases. I have 1 at 0. I have 1 at negative 4 because I'm looking where I get 0, right? 0 times anything is 0. And I have 1 more at negative 2. Do you guys see that? Those are the values that will make that a 0. So here's my sign chart. I'm going to put my sign chart right here in blue. It goes forever to the left, forever to the right. And this is F prime. And let's see, which one's my biggest negative? Okay, negative 4, negative 2, and 0. All right. This is the one that I'm looking at. I'm looking at this one right here. I guess you could look at the top one, but make life simple for yourself. I'm going to pick a number like negative 10. 4 times negative 10, that's a negative. You just care about positive or negative. 4 plus negative 10, that's also a negative. 2 times negative 10, negative 20 plus 4, that's still a negative. So negative times a negative times a negative is a negative. I'm going to pick a number between negative 4 and negative 2, like negative 3. 4 times negative 3, that's a negative. Negative 4 plus negative 3, that's a positive. 2 times negative 3 is negative 6 plus 4, that's a negative. So think about it. Negative times a positive times a negative. Positive. I'm going to choose a number like negative 1. 4 times negative 1, that's still a negative. 4 plus negative 1, positive. 2 times negative 1, negative 2 plus 4, that's a positive. Negative times a positive, that's a negative. And then if I choose a positive number like 1 or 2, 4 times 1, positive. 4 plus 1, positive. 2 times 1 plus 4, positive. Positive times a positive, positive. They want increasing, so I'm looking where the derivative is. So where's the derivative positive? There you go. And really, they should put brackets on the negative 4 and 2 and on the 0, but that's fine. Cool or not cool? All right, we got 2 left. Number 9. Find the intervals in which the function 3x minus 3 cosine x increases between 0 and 2 pi. Okay, take a derivative. F prime of x equals 3. And then the derivative of cosine is negative sine. Negative times a negative is a... So plus 3 sine x. Just throw it in the floor there, Crystal. Thank you. Man, those are heavy. I don't even know if I can pick that up. All right. Thank you, Crystal. Hopefully you have enough pre-cal knowledge. If you don't, that's okay. I don't want you to be a robot, guys. Think about this. Look what you have. You have a 3 in front of the sine, so the amplitude is 3, and your midline's at 3. So you have a wave where the max of that wave is a 6, and the min of that wave, what's 3 minus 3? Is it ever negative? No, my derivative is always positive. Well, it touches 0. 0 technically is not negative or positive, but you're never negative. Does that make sense? Yeah, f prime of x, in this case, is always greater than or equal to 0. It hits 0 many times, infinitely. Well, between 0 and 2 pi, it only hits it once, I think. Let me see. 3 plus 3 sine x equals 0. Sine, move it over there. 3 sine x equals negative 3. Sine x equals negative 1. 3 pi over 2. So between 0 and 2 pi, it only hits it once at 3 pi over 2. The 0. It only hits 0 once. But it's always above the x-axis. It touches the x-axis or above. So it increases in its entire domain. Because it never goes down. Because my derivative is always positive. It's never negative. Yeah. All right. Last one. Find the intervals in which f of x equals 2 cosine squared x is increasing. By the way, guys, is this helping you guys? Like, do you guys like it when we go over the UH quizzes? Yeah. Now you guys came in rowdy about. Okay, here we go. Okay. Rewrite this, guys, because sometimes you guys freak out and do a whole bunch of magic with that square there. So put that square right there. We're gonna do chain rule, and it's just baby chain rule. It's not a crazy one, guys. F prime of x equals 2 times 2 is 4. Leave the inside alone. Cosine x times derivative of cosine x, which is negative sine x. I'm going to equal this sucker to 0. Let me make it pretty. Positive. Yeah, I'm going to put the negative on the outside. Negative 4 cosine x sine x. Okay. The only time this is going to be 0, because I see a cosine x and I see a sine x, is at all these points on the unit circle. So that's, I'm only looking between 0 and pi. So x equals 0, x equals pi over 2, and x equals pi. But I know 0 and pi are endpoints. Oh, well, because cosine x and sine x is a product. And cosine is 0 at pi over 2 and at 3 pi over 2. And sine is 0 at 0 and pi. See? So it's all these numbers. It's all these radians. X equals 0, pi over 2, pi. Yeah, cosine of 0 is 1, but sine of 0 is 0. And then cosine of pi over 2 is 0, and sine of pi over 2 is 1. Yeah. And remember, I'm looking at cosine. This is all a product, and I'm looking at sine. See? So where's cosine 0? I guess maybe I should have put it down here like this. At pi over 2 and at 3 pi over 2, but we don't care about the 3 pi over 2 because we're only looking there. So who cares about that? Where is sine 0? Sine is 0 at 0 and at pi. Yeah. 0, pi, and I guess 2 pi, but we don't care about the 2 pi. And the pi is an endpoint. An endpoint. See? And the 0 is also an endpoint. So, yeah, we're about to do this. 0 pi, this is my f prime, and the only critical point I have is pi over 2, right smack in the middle. Okay. It's a little bit of pre-cal, but it's baby pre-cal. It's baby pre-cal, guys. I'm going to draw the unit circle right here to cut it up. Really, we're just looking at quadrant 1 and quadrant 2. Okay, here we go. Hey, guys, focus. All right. Between 0 and pi over 2 is cosine positive or negative. We're in quadrant 1. Cosine is the x-coordinates. Positive. What about sign? Positive. But notice you have a negative in the front. Negative times the positive is a negative. Put a negative. Now I'm looking at quadrant 2 between pi over 2 and pi. Between pi over 2 and pi. Cosine is negative, but sine is positive because you're above the x-axis. Does that make sense, guys? So what is negative times a positive? Positive. Okay, there it is. It wants increases. So I'm looking for what? Where the derivative is positive. So between what and what? There it is, guys. We got it. How do we feel? Do we feel like all this makes sense? All right, guys. It's 3 o'clock. I think you have enough time for one attempt, but it's your call. And we'll call it a day.